my SQL query found out what was the minimum goal scored by a player. So if I run this, you will see it will return me 3. So 3 was the least number of goals scored by one of the players. Now in my outer query, what SQL did was it searched for those goals where the value was equal to 3. So we wrote select star from players where goals equal to 3. Hence, if I run this, you will find the player who scored only 3 goals, and that player is Matt. Alright. Now the other way to do is using the limit operator. So this is more simpler than the previous method. I can write select star from players, order by goals. Now let me first run this SQL statement. If I run this, you can see we have ordered this in ascending order. So the person who has scored the least number of goals appears at the top, and the person with the player with the highest number of goals appears at the bottom. And from this table I only want the first row, and for that I can use the limit operator. So if I write limit 1, it will display only the first row. If I run it, you can see it shows me only the record for Matt. Moving ahead, now let's see the fourth question in our list. The question is, write the SQL query to find the player with the second highest number of goals. Now again, there are two methods to do it. One is by using limit and offset, and the other method is to use a subquery. So let's see both the methods. I'll first write my SQL query using limit and offset. So my query will be select star from players, order by goals, descending. Let me just run this. Alright, so here you can see my table has been ordered in descending order of goals. So Anthony has scored the most number of goals, then comes Daniel, followed by Sam, and at the end we have Matt, who scored the least number of goals. Now out of this, I want the player who scored the second highest number of goals, which is Daniel. So I want my SQL query to return this row that has player ID 103, name is Daniel, country is England, and goals is 7. For that, MySQL has two features. So I can use limit 1 followed by offset 1. So what this query does is it will offset one row, that is, it is going to offset the first row, or it is going to skip the first row and then print only the second row, because I have set my limit to 1. So let me just run it. You will see we get the desired result. The player name is Daniel and the number of goals scored is 7. Now the other method to do is using a subquery. Now let me write my subquery. First I'll write my outer query, which is select star from, and here I'll write my subquery select star from players, order by my column name, which is goals, in descending order. Here I'll limit it to 2. Then I'll give my alias name as T. Then I'll use order by goals limit 1. Let me just run it first. If I run this, you see here I get the same result. Now let's first break it down. I'm going to run this subquery first. So here I have select star from players, order by goals, descending, and limit is 2. Let me just run it. So the selected SQL query returns the first two rows ordered by goals, and if you see here clearly, we have again ordered the value returned in ascending order, which means from this table, if I order this table in ascending order, Daniel should appear first, and out of that I'm limiting my result to 1, so it will print only Daniel. If I run this again, you can see I have the desired output. Now let's check the fifth question in our list. Given the below email table, write a SQL query to find the distinct domain names from the email column. So if you consider this as my email table, the domain names are gmail.com, yahoo.in, and we have hotmail.com. These are the distinct domain names. Now to solve this task, again we have two methods. Either you can use the substring underscore index function, or you can use the substring function. Now the substring underscore index function returns a substring of a given string before a specified number of delimiters. So let me first use the first method. Okay, so here on my SQL workbench, I'll write select. I'll use the keyword that is distinct. Then I'll use my function, which is substring underscore index. Here, substring underscore index will take three parameters. The first is the original column name, which is email, followed by the delimiter I'm looking for, that is @. So I'll put @ with single quotes since it is a text or a character, and then I'll give the number of times to search for the delimiter. Here it is going to be -1. So you can either give a positive value or a negative value. If it is a positive number, then this function will return all to the left of the delimiter. If it is a negative number, the function returns all to the right of the delimiter. Alright. And then I'll give an alias name as, say, domain name from my table, that is email. If I run this, you can see I have the list of all unique domain names or distinct domain names that we saw in our table. This is one of the ways. The other way is to use the substring function. Now the substring function extracts a substring from a string starting at any position. So let me write my SQL query. I'll write select distinct. I'll then give my function as substring. Here substring will take in two parameters. The first parameter is the column name, which is email ID here. So I'll write email. I'll give a comma. Next, I want to find my delimiter. So for that, I'm going to use another function called locate. And here I want to locate the index position of @. So I want to give my delimiter as @ followed by the column name, which is email. And then I want to fetch everything after the delimiter, and for that I'm giving +1. Again, let me give a domain name as the alias name from email. If I run this, you will see we'll get all the unique domain names: Gmail, yahoo.in, and hotmail.com. So these were the two ways to solve the same problem. Now moving ahead, let's look at our sixth question. So our question is, write the SQL query to find duplicate records from a table without using a temporary table. Now, one of the other variants of this question is to delete all the duplicate records from a table without using a temporary table. Now to solve such queries, you can use the group by and the having clause. Let's look at how to do it. So here on my SQL workbench, I'll write my select query as select star, and then I want to count all the duplicate values. Let me give it an alias name as frequency from my table name, which is employee here, and then I want to group by name having count star greater than 1. Let me just run it. Alright, you can see it has returned me 2 rows. The name is Angela and Mike, and the frequency is 2. Let me just verify this to see all the repeated records that were present in my employee table. So I'll write select star from employee. If I run this and scroll down, here you can see Angela is present here as well as at the bottom. Similarly, we have Mike present twice in the table, and hence our SQL query returned only Angela and Mike because they were repeated twice. You can see the frequency here. So let's now look at our 7th question. Given the below employee table, I want to write a query to find all the even and odd records from the table. So as you can see, there are 2 ways to do it. One is to use a subquery, and another you can use the mod function. So let me show you both the ways. Alright, so let me run this SQL query to see all the values present in the employee table. So if you see, the last column, which is the employee ID column, has all the employee IDs as unique values. So I'm going to use this in my where condition. So to find out all the even records, I'll write my SQL query something like this. I'll write select star from employee, which is my table name, where employee ID, then I'm going to give my in operator, and inside the in operator I'm going to write my subquery, which is select employee ID from employee, where employee ID %2 is equal to 0. This means wherever my employee ID is divisible by 2, it will return only those records. So let me just run it. There you go. So here we have easily fetched only the even records from the table. Similarly, if you want to get only the odd records from the table, you can use the mod function also. So I'll write select star from employee, where here I'm using the mod function, mod empid comma 2 is not equal to 0. So I'll use the exclamation mark is equal to 0. So if I run this, it will return only the odd employee IDs. You can see it here. So those were the 2 ways in which you can fetch the even and odd records from the table. Now let's see our 8th question. So here is the question. Below is the customer table. Write a query to get the first purchase of each customer. Now if you look at the table, there are 3 customer IDs, 101, 102 and 103. Now customer 101 made its first purchase on 2nd October 2018, which is this one, and customer 102 made its first purchase on 5th of October 2018. And since we have just one record for customer ID 103, so this is going to be his or her first purchase. So I want to return 101 phone, 102 tablet and 103 books. To do this, we are going to use an inner join. If you can see, I have used an inner join and I have also used a subquery. Let's write this query on my SQL workbench. Okay, so this query is going to be a little complicated. If you have any questions, then please put it in the chat section. We'll be happy to help you. So I'll start with select. I'm going to take an alias name as t dot. I'll write cust underscore id comma t dot purchased at comma, the next field I'm going to select is t dot item from customers as T. Next, I'm going to write my inner join, and inside the inner join I'll write my subquery, which is going to be select customer ID, comma, I'm going to take the minimum value from the purchased at column, which is my date column. Close this. I'll give another alias as min underscore purchased underscore at from my table name is customers. Then I'm going to group it by 1. Here 1 means the first column that you have put in the select statement, which is customer ID. So I'm grouping by customer ID. I close the bracket, and everything I'm going to give an alias name as T1. Now I'm going to join on T dot customer ID is equal to T1 dot customer ID, and my next condition would be T dot purchased at is equal to T1 dot min underscore purchased underscore at. I'll give a semicolon. I would request you to go through this SQL query in a detailed manner so that you understand it line by line. Let me just run it now. If I run it, okay, it has thrown me an error which says table SQL underscore IQ customer does not exist. The reason is my table name is customers. Alright, so let me run it once again. Okay, so there's one more error. It says unknown column purchases at. So we had made a spelling mistake here. It should be purchased at. Now let's try and run it. Alright, there you go. So for customer ID 101, the first purchase was made on 2nd of October 2018. Likewise, for customer ID 103, the first purchase was made on 5th of October. And similarly for customer ID 102, the first purchase was made on 5th of October again. Now moving to the 9th question. So here we have a weather table. We want to write an SQL query to find all the date IDs with higher temperature compared to its previous dates. So if you see, we have a date ID column, we have the date and the temperature. Using this table, I want to find those IDs with higher temperature compared to its previous dates. So if you look for date ID 1, the temperature is 32. For date ID 2, the temperature is 31. For date ID 3, the temperature is 30.8. Now if you clearly notice, for date ID 4, the temperature is 31.5, which is actually higher than the previous date ID, which is 30.8. Similarly, for date ID 5, the temperature is 33, which is again higher than the previous date, which is 31.5. Now if you look at the date values, they start from 10th of March till 15th of March 2020. Now to solve this query, we are going to use SQL joins again, and I'm going to use a function called to_days. Now MySQL to_days function returns the number of days between a given date and year 0. So let's go ahead and write this SQL query. Alright, so first let me select all the rows from the temperature table which we are going to use for this particular question. I'll run it. Alright, there's some error. Actually the name of the table is weather and not temperature, so I'll write weather. Let me run it. Okay, so here you can see these are all the rows present in the weather table, and as I explained, I want to return only the date ID 4 and this date ID which is 5. Now one thing I want to make it clear here, that this date ID should actually be 6, so there was a mistake while creating the tables. Please consider this date ID as 6 and not 5. So I want to return date ID 4 and date ID 5. Alright, so let me go ahead and write my SQL query. So I'll write select, I'll write a dot date underscore ID from weather as A, comma, I'll join weather as B, where A dot temperature is greater than B dot temperature, and I'll give my condition, and I'll use the function to underscore days and give my value a dot date underscore val is equal to, I'll use the function again, to underscore days, b dot date underscore val plus 1. Now I would like to know from our viewers, why have we used plus 1 in the where condition? So please put your comments in the chat section. Let me just run it. There you go. So here you can see my SQL query has returned the date ID 4 and 5, which means these are the date IDs where the temperature was higher compared to the previous dates. Alright. Now coming to the last question on this interesting session on SQL interview questions for data scientists. So there are two tables. One is the authors table and the other is the books table. I want to write an SQL query to find the second highest author who sold the most number of books. Now this is going to be my SQL query. Again, we are going to use joins on both tables author and books along with limit and offset operators. So let me show you how to do it. So first I'm going to join my author table and the book table. So I'll write select a dot author underscore name, comma, I'm going to find the sum of copies sold from the books table. So I am giving my alias name as b dot copies underscore sold, which is my table name. I'll give an alias as sum underscore sold from author as A, join books as B on, I'll write b dot book underscore name is equal to a dot book underscore name. Now I'm using book underscore name as my criteria because book underscore name is the common column to both the tables. Then I'll use a group by clause. I'll write group by a dot author name. Then again I'm going to use an order by clause. I'll write order by sum underscore sold, and I am going to order it in descending order, so I'll write DESC. I'll set my limit as 1 and offset as 1. If I run this, you will find that my SQL query has thrown an error. The reason is we have used a column called bull underscore name, so it should be book underscore name. There was an error here. Let me run it again. Okay, there was another small error. This should be sum underscore sold. Let's run it. There you go. So my SQL query has returned author 3 because author 3 sold the second highest number of books. Now let me just remove the last few lines in the script. Let me just run it now. If I run this, you can see author 1 sold the highest number of books, followed by author 3 who sold the second highest number of books, and then it was author 2 who sold the least number of books. So if I write limit 1 and offset 1, what this line of code will do is it will skip the first row and print the next row. So let's just run it. And you can see it has returned me the author who sold the second highest number of books.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simply-Learn. Click on the link in the description to know more.
In today's session, we'll be discussing some of the top mathematics interview questions for data science. These questions are based on various topics in mathematics such as statistics, probability, and linear algebra. So let's begin with our first question. The first question we have is, what is normal distribution? Now, normal distribution is a probability distribution that is used to check how your data is distributed. Your data could be spread out to the left or to the right, but in many cases, the data tends to be around a central value with no bias left or right, as you can see on your screens. Now, this is called a normal distribution where half of the points are to the left and another half of the points are to the right of the center. Now, such a distribution contributes to 68% of the data falling within one standard deviation of the mean. Then we have 95% of the data falls within second standard deviation of the mean. So if you add up 13.6% and the 68% plus 13.6%, this will result to 95% of data falling within two standard deviations of the mean. And finally, we have close to 99.7% of the data falling within three standard deviations of the mean. So this is what a normal distribution is all about. Now moving on to the next question. So what are the different measures that are used to summarize a distribution? Now, to get more idea about the data and summarize a distribution, you can use three types of statistical measures. The first we have central tendency measures, then we have variation measures, and finally we have shape measures. Now under central tendency measures we have mean, median, and mode. Now the mean is the most frequently used measure of central tendency in a data set. Let me take you to the Wikipedia page and explain you what mean exactly is. Okay, so here you can see on the Wikipedia page it has the formula to calculate the mean of a distribution. So this is basically the summation of all the data points divided by the total number of data points. So here you can see an example. We want to find the arithmetic mean of 5 values which are 4, 36. We'll pick the fourth element from our ordered set of points, that is 6 here, and hence 6 is the median for this ordered set of points. Now if you have an even number of observations, as you can see here, total we have 8 observations. Now the median becomes xn by 2 plus xn by 2 plus 1 divided by 2. So your median becomes the mean of the middle two numbers, that is 4 plus 5 by 2, which is 4.5. Alright. Now the next statistical measure we have under central tendency is called the mode. So the mode is the most frequently occurring value in a set of data points. So here you can see an example. We have a set of data points 6, 3, 9, 6, 6, 5, 9, 3. So your mode is going to be 6 here, since 6 is occurring thrice in the set of data points. Okay. Now under variation measures we have variance, standard deviation, and interquartile range. So first look at what variance is. So variance is the average of the squared differences from the mean. Now this is the formula for variance. You can see xi represents the individual set of data points and mu represents the average value. So mu is nothing but the summation of all the data points divided by the total number of data points. So this is your formula for variance. Next we have standard deviation. So standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation suggests that the values tend to be close to the mean, while a high standard deviation suggests that the values are very spread out. Now here you can see the formula for variance. Now this is denoted by sigma, and your standard deviation is nothing but the square root of variance. So here you can see the formula for variance. You have xi minus your mu square, which is the mean of all the data points, divided by n. Then we have the interquartile range, which is also known as IQR. So IQR is a measure of variability based on dividing a data set into quartiles. So an interquartile range measures where the bulk of values lie. So the formula for IQR is Q3, which is the third quartile, minus the first quartile. So here you can see we have a list of data points. Then we are ordering the data points first, and then we cut the list into quarters. So first you have the Q1, then you have Q2, and finally you have Q3. So for these set of data points, your IQR is going to be 7 minus 4, that is 3. Then we have shape measures. So under shape measures we have skewness and kurtosis. So skewness is a measure of symmetry. Your distribution is symmetric if it looks the same to the left and the right of a center point. Now they are majorly of two types. One is called negative skew, or which is also known as left skew. Then we have positive skewed or right skewed. And finally we have kurtosis. So kurtosis is a measure of the tailedness of a probability distribution. It defines how heavily the tails of a distribution differ from the tails of a normal distribution. So if you consider these distributions, the kurtosis will calculate the tailedness, which is actually these areas of a distribution. Now let's look at a third question. So the question is, create a sparse matrix in Python. Now in numerical analysis, a sparse matrix or a sparse array is a matrix in which most of the elements are 0. Now there are multiple ways to create a sparse matrix. I'll show you two ways to create a sparse matrix. So let me take you to my Jupyter notebook, where I'll create a matrix first, and then we'll see how to create sparse matrix out of it. So I am on my Jupyter notebook here. First let me import the necessary libraries. So first I am going to import numpy as np, and then from scipy we'll import sparse. I'll run this cell. Okay. Next let me go ahead and create a matrix. I'll use the np.array function, and within this function I'll create a 3 cross 3 matrix, and I'll assign the elements. So my first row will have 1 2 3. Next we'll have 4 5 6. Then we'll have 7 8 and 9. Alright, let me run this cell. Okay, now let me go ahead and print my matrix. So I'll use the print function, and let's say I'll pass in a message that is original matrix, comma, and then pass in my variable name, that is matrix. Let's run it. So here you can see I have my original matrix. It is a 3 cross 3 matrix and has 9 elements in it. First let's see how using dictionary of keys you can create a sparse matrix. So for that I'll write the print statement, and then I'm going to use a function which is called DOK, that stands for dictionary of keys underscore matrix, and I'll pass in my variable name, which is my original matrix. So if I run this, you can see I have got my dictionary of keys sparse matrix. Next I'll show you how using diagonal storage paste you can create a sparse that I am going to use another function, that is sparse.dia, which stands for diagonal underscore matrix. And within this function I'll pass in my original matrix variable name. If I run this, you can see we have created diagonal storage based sparse matrix. Alright. Now moving to the next question. So given below is a matrix. Now we need to find the inverse of this matrix. Now the inverse of a square matrix A, which is sometimes called as a reciprocal matrix, is a matrix A inverse such that the dot product of A and A inverse is always I, which is an identity matrix. Now in NumPy we have a function which you can see here, that is np.linalg.inv, that helps you find the inverse of a matrix. Let me show you on the Jupyter notebook. First, let me print my original matrix. Alright, now here I'll use the function with mint, that is np.linalg.inv, which stands for inverse, and then pass me my variable name, that is matrix. If I run this, you can see I've got the inverse of my original matrix. Now moving to our fifth question. So this question is related to probability. You call 2 Uber X and 3 lifts. If the time that each takes to reach you is IID, what is the probability that all the lifts arrive first? Next, we want to find what is the probability that all the Uber X arrive first. Now this is fairly a simple question. First, let's look at all the lifts arrive first. Then first we need to find the probability that the first car is a lift, which is going to be 3 by 5, since we have 3 lifts and total we have 5 vehicles. Next, we want to find the probability that the second car is a lift, which is going to be 2 by 4. Third, we need to find the probability that the third car is also a lift, which is 1 by 3. Now arrive first is going to be the multiplication of the product of the above 3 probabilities, that is 3 by 5 into 2 by 4 into 1 by 3, which is nothing but 1 by 10. Next, let's say you want to find for all the Ubers that arrive first. So you need to find the probability that the first car is Uber, which is nothing but 2 by 5, since we have 2 Ubers. Next, the probability that the second car is an Uber is going to be 1 by 4. So the total probability that all the Ubers arrive first is going to be the product of 2 by 5 and 1 by 4, which is also 1 by 10. Now moving to the sixth question. The mean, median and mode of a distribution are 30, 25 and 20. We need to determine if the distribution plot will be positively skewed or negatively skewed. So you can see from the distribution graph, the mean is to the right, median to the middle and mode to the left. So since the value of mode is less than the mean and median, the data will be positively skewed. And similarly, the skewness of the distribution is on the left if the mean value is less than the median and the mode occurs at the highest frequency of the distribution. Now the next question we have is, what are covariance and correlation? So covariance and correlation are measures that help you understand the relationship between two continuous variables. So covariance tells the direction of the linear relationship between two random variables. The direction means if the variables are directly proportional or inversely proportional to each other. So increasing the value of one variable might have a positive or a negative impact on the value of the other variable. Now covariance can take any value between minus infinity and plus infinity. So below you can see the formula to calculate the covariance. So you have summation xi minus x bar or x dash here represents the mean, xi represents the individual points, then this is multiplied by yi minus y dash or the mean of y divided by the total number of observations. Next, we have correlation. So correlation explains the change in one variable leads to how much proportion changes in the second variable. Correlation tells how strongly two random variables are related to each other. It takes values between -1 and +1. A negative correlation means they are inversely proportional to each other. A positive correlation means they are directly proportional to each other. If the correlation coefficient is 0, then there is no linear relationship between the variables. So here below you can see the formula to calculate the correlation. Now moving to the 8th question. So what are the sampling methods used in data science? Now sampling is a statistical technique that is used to select, manipulate and analyze a subset of data points and find patterns and trends in the large data set being examined. Now there are two types of sampling methods. We have probability sampling and non-probability sampling. Now under probability sampling we have something called as random sampling. So in random sampling, every individual is chosen entirely by chance and each member of the population has an equal chance of being selected. Then we have stratified sampling. So in stratified sampling, subsets of the population are created based on a common factor and samples are randomly collected from each other. Now talking about systematic sampling. So in systematic sampling, a sample is created by setting an interval at which to extract data from the larger population. An example could be selecting every 5th row in a spreadsheet of 100 items and creating a sample size of 20 rows for analysis. And finally, under probability sampling we have cluster sampling. So in a cluster sampling, subgroups of the population are used as the sampling unit rather than individuals. So the population is divided into clusters and a whole cluster is randomly selected to be included in the analysis. Now let's look at the sampling methods that are present under non-probability sampling. So first we have convenience sampling. So for convenience sampling, the samples are selected based on the availability. So this method is used when the availability of samples is rare and costly. So based on convenience, samples are selected. Second, we have quota sampling. So quota sampling depends on some preset standard. The proportion of characteristics in sample should be the same as the population. Next, we have purposive sampling. It is also known as judgmental sampling. You select members of sampling on the basis of the objective of the study. It is very useful when you want to reach a particular or targeted sample quickly. Finally, we have snowball sampling. So the snowball sampling technique is used in situations where the population is completely unknown and rare. Now coming to the 9th question in our list. So explain what p-value tells about statistical significance. So p-value is a statistical test that is used in hypothesis testing. It helps you to decide whether to accept or reject the null hypothesis. The null hypothesis, represented as H0, is a commonly accepted fact. It is the opposite of alternative hypothesis. Researchers and scientists work to reject or disapprove the null hypothesis. They come up with an alternative hypothesis that they think explains a phenomenon and they work to reject the null hypothesis. For example, null hypothesis or H0 could be the world is flat and an alternative hypothesis could be the world is round. So lower the p-value, the greater the statistical significance of the observed difference. Now the p-value is just one piece of information you can use when deciding if your null hypothesis is true or not. The p-value lies between 0 and 1 as you can see here. The threshold for p is set to 0.05. When the value is below 0.05, the null hypothesis is rejected. Now coming to the final question in our list of mathematics interview questions for data science. So the question is, what do you understand by type 1 versus type 2 error? Now in statistical theory, the statistical error is an integral part of hypothesis testing. In statistical hypothesis testing, no test is ever 100% certain. That's because we rely on probabilities to experiment. Even though hypothesis tests are meant to be reliable, there are two types. So type 1 error occurs when the null hypothesis is true and we reject it. It is also known as a false positive finding or conclusion. An example could be an innocent person is convicted. And type 2 error occurs when the null hypothesis is false and we accept it. It is also known as false negative finding or conclusion. An example could be a guilty person is not convicted. So here you can see we have a reality where your null hypothesis is true, and here we have the null hypothesis is false, and this is where the type 1 error lies. So this can also be represented as false positive, where the null hypothesis is true and we reject it, and this could be false negative, where the null hypothesis is in reality it's false and we accept it. In our previous video, we had discussed the important interview questions on mathematics, statistics, probability and linear algebra that are often asked in any data science interview. Today, we will learn about some of the machine learning and deep learning interview questions. So let's begin with our first question. The first question is how to detect outliers in data. So in data analytics and machine learning, you often find data points that lie at an abnormal distance from other points in a random sample from a population. Those are called outliers. Now, outliers in data can significantly impact any prediction analysis. There are majorly three different methods to treat outliers. First, we have the univariate method. It is one of the simplest methods for detecting outliers. The univariate method uses box plots. A box plot is a graphical display for describing the distributions of the data. Box plots use the median and the lower and upper quartiles. This method looks for data points with extreme values on one variable. Next, we have the multivariate method. So the multivariate outliers can be found in an n-dimensional space having n features. We look for unusual combinations of all the variables in this method. Finally, we have Minkowski error. This method reduces the contribution of potential outliers in the training process. The Minkowski error is a loss index that is more insensitive to outliers than the standard mean squared error. Now moving on to the second question, what is a confusion matrix? So a confusion matrix is a table that is used to describe the performance of a classification model on a set of test data for which the true values are already known. The target variable has two values, positive or negative. The columns represent the actual values of the target variable, which you can see here. The rows represent the predicted values of the target variable, which you can see here. Now there are four important terms that are related to confusion matrix. First, we have true positive, which is this one. So in true positive, the predicted value matches the actual value. So the actual value was positive and the model also predicted a positive value. Then we have true negative, which is also represented as Tn. The true negative depicts the predicted value matches the actual value. Now the actual value was negative and the model predicted a negative value. Next we have false positive. Now false positive is also known as type 1 error. In false positive, the predicted value was falsely predicted. The actual value was negative, but the model predicted a positive value. Finally, we have false negative. Now false negative is also known as type 2 error. So in false negative, the predicted value was falsely predicted. The actual value was positive, but the model predicted a negative value. Now moving to our third question, which is explain the ROC curve. Now the ROC curve is one of the most important evaluation metrics for checking the performance of any classification model. ROC stands for Receiver Operating Characteristic. Receiver Operating Characteristic or ROC curve is a method to compare the diagnostic tests. The ROC curve is created by plotting the true positive rate against the false positive rate at various threshold settings. So here on the y-axis you have the true positive rate, on the x-axis we have the false positive rate. The true positive rate indicates the proportion of observations that were correctly predicted to be positive out of all positive observations. Similarly, the false positive rate is the proportion of observations that are incorrectly predicted to be positive out of all negative observations. You can take an example. Suppose in medical testing, the true positive rate is the rate in which people are correctly identified to test positive for the disease in question, let's say the coronavirus testing. ROC does not depend on any class distribution. This makes it useful for evaluating classifiers predicting rare events such as diseases or disasters. Now moving to the fourth question, we have what are the assumptions for linear regression? So linear regression analysis is used for modeling the relationship between a single dependent variable y and one or more feature or predictor variables. Some of the important assumptions for linear regression are, so first, they should have linearity. So linear regression needs the relationship between the independent and the dependent variables to be linear. It is also crucial to check for outliers since linear regression is sensitive to outlier effects. Next we have homoscedasticity. Homoscedasticity illustrates a situation in which the error term, that is, the noise or random disturbance in the relationship between the features and the target variable, is the same across all levels of the dependent variables. Third, we have independence. So observations should be independent of each other. Finally, we have no multi-collinearity. So there should be little or no multi-collinearity. Independent variables should not be too highly correlated. Now moving to our fifth question in our list of interview questions. The question is, what is regularization in machine learning? Explain the L2 regularization. So regularization is a machine learning technique that is used to reduce the errors by fitting the function appropriately on the training set in order to avoid overfitting of data. So overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. So here you can see we have a nice plot which shows how overfitting of data can be visualized, and here we have a good fit line over the same data points. So this is also known as the regression line. Now L2 regularization is also known as ridge regression. So ridge regression modifies the overfitted model by adding the squared magnitude of coefficient as a penalty term to the loss function. So on the right you can see a set of data points plotted, and we have our linear regression line, and here we are calculating the cost function for the ridge regression line. So our cost function is actually loss plus lambda into summation of w squared, where loss is actually the sum of squared errors or squared residuals. Lambda stands for penalty for the errors. W is called the slope of the curve or line. Okay, now consider a case where there are 2 points passing through the linear regression line. Now if you calculate the cost function, we get the value as 1.69. So here we have assumed that loss is 0 since the 2 points lie directly on the line. We have taken lambda to be 1 and w is 1.3. So if you use this function or this formula, you get the cost function as 1.69. Now moving ahead, let's consider another situation where we'll calculate the same cost function for the ridge regression line. There is some loss for both the points as they are not on the same line. So here you can see the sum of squared residuals is 0.05, which actually is the sum of 0.2 square. I'm assuming this as 0.2 and 0.1 for this one. So if you square both and add it, the value is 0.05. A lambda is again 1 and w we have assumed to be 0.6. Now if you find the cost function, the value is 0.41. Let's draw the linear regression line and the ridge regression line with all the points. We find that the ridge regression line has the best fit since its cost function is less.
If getting your learning started is half the battle, what if you could do that for free? Visit ScaleUp by Simply Learn. Click on the link in the description to know more.
Now coming to the sixth question, what are the different methods to split a tree in a decision tree algorithm? So there are 3 methods to split a decision tree. First we have variance. So reduction in variance is an algorithm that is used for continuous target variables. This algorithm uses the standard formula of variance to choose the best split. So here you can see the standard formula of variance, which is summation of x, that is all the individual points, minus x bar, which is the mean, squared divided by the total number of observations. Now the split with lower variance is selected as the criteria to split the population. Now the steps to calculate variance is, you need to calculate variance for each node, and then you need to calculate for each split as the weighted average of each node variance. Moving ahead, the second method we have is information gain. So information gain is used for splitting the nodes when the target variable is categorical. It works on the concept of entropy. Now the degree of disorganization in a system is known as entropy. So here you can see the formula for information gain, which is 1 minus entropy. Finally we have Gini impurity. So Gini impurity is the probability of incorrectly classifying a randomly chosen element in the dataset if it were randomly labeled according to the class distribution in the dataset. So below you can see the formula for Gini impurity. So we have 1 minus summation of pi whole square, where n represents the number of classes and p of I represents the probability of randomly picking an element of class I. Now moving to the 7th question. So the question is, how do we find the optimum cluster value in k-means clustering algorithm? Now there are two methods to find the optimum cluster value. So first we have the elbow method, which is one of the most well known for finding the optimum number of clusters. So in this method you need to calculate the within cluster sum of squared errors for different values of k and choose the k for which within cluster sum of squared errors first starts to diminish. So in the below plot of squared errors versus the number of clusters k, you can see at k is equal to 4 the squared error starts to diminish. So hence our optimum k value is 4. Next we have the silhouette method. So the silhouette method measures how similar a point is to its own cluster compared to other clusters. The average silhouette method computes the average silhouette of observations for different values of k. The optimum number of clusters k is the one that maximizes the average silhouette over a range of possible values for k. The silhouette score reaches its global maximum at the optimal k. So in our case, the average silhouette reaches maximum at k is equal to 2, which you can see here. So our optimum cluster value will be 2 here. Moving ahead, the 8th question in our list is, how does the pooling layer work in a convolutional neural network? So the pooling layer performs a downsampling operation in order to reduce the dimensionality of the feature map. So in the pooling operation, you slide a two-dimensional filter over each channel of feature map and summarize the features lying within the region covered by the filter. It is a common practice to periodically insert a pooling layer in between successive convolutional layers in a convolutional neural network architecture. So the pooling layer operates independently on every depth slice in the input and resizes it spatially using the max operation. So in the diagram shown here, you can see we have a rectified feature map. We are using a 2x2 filter and performing a max pooling operation. So consider this as the filter. If you perform the max operation over the values, let's say 0, 5, 3 and 1. So considering this one, our pooled feature map maximum value will be 5. Similarly for this chunk of data, it is going to be 7. Next, if you slide the filter over this square frame, you get 8, and similarly here you get 6. So this is also known as a pooled feature map. Moving ahead, the 9th question in our list is, how does LSTM network work? So long short-term memory networks are a type of recurrent neural networks that are capable of learning order dependence in sequence prediction problems. So remembering information for long periods of time is practically their default behavior. Now LSTMs also have this chain-like structure which you can see here, but the repeating module has a different structure. So instead of having a single neural network layer, there are 4 interacting in a very special way. Now you can see these are called as gates. These gates contain sigmoid activations. A sigmoid activation is similar to the tanh activation. Instead of squishing values between -1 and +1, it squishes values between 0 and 1. An LSTM has 4 gates. Now these are called forget, remember, learn and use or output. So if you see this, in the first step, we use the forget gate that decides what information should be thrown away or kept. The information from the previous hidden state and the information from the current input is passed through the sigmoid function. Values come out between 0 and 1. So if the value is closer to 0, it means you need to forget that information, and if the value is closer to 1, it means you need to keep that information. Next we have the input gate. So the input gate is used to update the cell state. First we pass the previous hidden state and the current input into a sigmoid function that decides which values will be updated by transforming the values to be between 0 and 1. 0 means not important and 1 means important. You also pass the hidden state and current input into the tanh function to flatten the values between -1 and +1. This helps to regulate the network. Then you multiply the tanh